Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss beta spectrum and Pauli's prediction of neutrino. Let's begin. What is beta spectrum? Beta spectrum is the distribution of beta electron energy, and it is found that the beta spectrum is continuous, having energies ranging from 0 to a certain well defined maximum limit, which is called the endpoint energy. Endpoint energy, that is the maximum energy of emitted beta particle. When we plot the graph between electron energy along x axis and relative number of electrons along y axis, that graph is looking like this. That graph is totally experimentally observed data. So, the beta electron energy here we found continuous rather than discrete, and that energy ranges from 0 to maximum energy, and that maximum energy we called, that is called the endpoint energy. Endpoint energy. At different energy, the relative number of electrons also different. Let us come to beta decay process, and under that beta decay process we understand that beta spectrum. When the radioactive nuclei are unstable, they try to stable by adopting various type of decay process. It may be alpha decay, beta decay or gamma emission. In that obsession, when beta decay occurred, so a proton either converted into a neutron or a neutron is converted into a proton in order to stabilize that nucleus. Stability of nucleus based upon the neutron proton ratio. In beta decay, either a proton converted into neutron or a neutron converted into proton. Due to that mode of operation, we classify it is beta minus decay or beta plus decay, and another form is K capture. In that of session, we analyze by taking beta minus decay and beta plus decay. In beta minus decay, we see this is the parent nuclei, atomic number Z, mass number A. Under that of beta minus decay, we obtain the daughter nuclei with atomic number increased 1 unit, mass number same, and an electron is emitted. Here a neutron is converted into a proton with the release of an electron. Similarly, for beta plus decay, This is the parent nuclei, daughter nuclei with the atomic number decreased by 1 unit with the emission of positron. In that of situation, a proton converted into neutron with the emission of positron. In this decay process, we obtain the energy. The energy is always maximum amount of energy, which is the endpoint energy. But when we plotting that graph in between electron energy and the relative number of electrons, so we see that the beta spectrum which is continuous rather than a particular value or a discrete value which is endpoint energy. So, there is no clarification regarding that energy, or it can't explain the beta spectrum. During that beta decay, it is seen that it violates some basic law like conservation of energy, conservation of momentum and conservation of spin. How that beta decay violates conservation of energy? For conservation of energy, for calculation, it is seen that energy of a nucleus which is emitting beta particle decreases by an amount equal to the endpoint energy of that of continuous spectrum. This is the endpoint energy of that continuous spectrum. That one is a beta decay process. In that of beta decay process, we see under calculation of such energy of that of nucleus, that is the parent nucleus, which emit the beta particle decreased by an amount equal to that of endpoint energy of that of continuous spectrum. But most of the beta particles emitted have energies much smaller than that of endpoint energies. Most of the beta particles have the energies in that range. Therefore, the law of conservation of energy is violated. During that beta decay, as we considered here, if we analyze the energy for that beta decay, we see it violates the law of conservation of energy. Next, how law of conservation of momentum is violated? If we assume the parent nucleus at rest and it decays into two particles, one is daughter nucleus, another one is electron. One is daughter nuclei, another one is electron. According to the law of conservation of linear momentum, the daughter nucleus and the emitted beta particle must move along a straight line, and these two are opposite direction having equal momenta. If the direction of daughter nuclei in this way, so the emitted electron, that is the emitted beta particle, its opposite, and the magnitude of these two momenta are equal, but directions are opposite. But actually, in that of beta decay, we do not see that type of directions in between daughter nuclei and the ejected electron. Therefore, it say this is the violation of law of conservation of linear momentum. Next, for spin, from the beta decay we see that the neutron or proton has spin half, whereas the electron with spin plus minus half. Therefore, it violates the law of spin conservation. Look here, neutron, it is having the spin half, proton again the spin half, electron, either plus minus half. Therefore, that is half spin, and the spin of that side either 1 or 0. Therefore, it violates the conservation of spin. The spin is not conserved during that of beta decay process. Due to these aspects, we see the scientist Pauli, in order to explain these aspects, in 1930, Pauli the name of the scientist Pauli predicted a particle named as neutrino. Particle neutrino. So, basic properties of neutrino, he hypothesized as neutrino it has chargeless, massless, spin half, velocity equal to speed of light, that is c. It has an antiparticle antineutrino. These are some basic properties of neutrino as predicted by the scientist Pauli. So, when that particle is introduced, neutrino, in that of beta decay process, that expected particle here is antineutrino, denoted by nu bar, that is antineutrino. Similarly, for beta plus decay, it is neutrino and is denoted by nu, that is the neutrino. Okay. By taking that new particle, let we confirm the violations of these laws are verified or not. Look here, in that of expression for spin, that antineutrino have the spin half. If we prefer half half 1 and then minus of that half, then it will be equal to half to that of spin. So, spin is conserved. Next, for beta plus decay, if it is half, the spin of this has half of 1 and the spin of that one is also chosen either plus half or minus half. Accordingly, the spin is conserved. Therefore, by taking that hypothetical particle, it verify the law of conservation of spin, momentum and energy. Verify the law of conservation of spin, momentum and energy. How these are verified? In case of energy, the total energy of a beta particle and a neutrino is constant, which is equal to the endpoint energy, and it is hypothesized according to that neutrino hypothesis. According to that neutrino hypothesis, a low energy beta particle is accompanied by high energy neutrino and vice versa. Means a high energy beta particle is accompanied with low energy neutrino. In this way, that energy is conserved. Again, for momentum, is conserved just by taking the resultant of nucleus the resultant of daughter nuclei beta particle and the predicted particle daughter nuclei, beta particle and predicted particle when you consider. So the momentum is conserved and spin is conserved as the spin is half. In this way all these laws, those are violated, now conserved by taking that particle neutrino and its antiparticle antineutrino. So here with the help of this video lecture we understand the concept of beta spectrum and Pauli's prediction of neutrino, that is beta spectrum. Next, during beta decay we see how these processes violates conservation of energy, momentum and spin. Therefore, for energy we see how energy is violated, for momentum how linear momentum is not conserved and how spin is not conserved without taking these predicted particles. After predicting this particle which is called neutrino, it has charge less, mass less, spin half and velocity equal to the speed of light and its antiparticle is antineutrino. Then these violated laws are verified. As energy is verified by taking the total energy of beta particle and neutrino is constant, which is equal to the endpoint energy. In this way a low energy beta particle accompanied with high energy neutrino and vice versa. So the energy is conserved. Next, the linear momentum again conserved by taking the resultant of daughter nuclei, beta particle and that of predicted particle. And finally spin is conserved. We see here how spin is conserved. Therefore the predicted particle neutrino is useful to verify these violated laws. So with this useful and informative notes, let me wind up the session. Thank you.